Dr. V. Anitha Rani, Associate Professor of Chemistry from Institute of Aeronautical Engineering. So in the previous class, we have discussed about difference between thermoplastic resins and thermosetting resins and the compounding of plastics. So in compounding of plastics, we have discussed that to improve the property of the plastics like hardness and to improve the converting straight chain polymers into cross-linked polymers. So we have used here catalyst. So we have added ingredients to the plastic resins, okay, that is called compounding of plastics, to improve the property of the plastics and to get the good finishing products. So today we are going to discuss about preparation, properties and applications of polyvinyl chloride and Teflon. So in preparation of polyvinyl chloride, so first we have to prepare the vinyl chloride. So vinyl chloride is prepared by treating acetylene with hydrogen chloride at 60 to 80 degrees centigrade in the presence of metal chloride catalyst. So we will take the acetylene and we will add to the acetylene, we are adding HCl and we are maintaining the temperature 60 to 80 degrees centigrade. So we will add metal chloride catalyst. So we can prepare the vinyl chloride. So we will use this vinyl chloride and we will add a number of vinyl chloride molecules undergoing free radical chain polymerization and we get the polyvinyl chloride. So already we know how to prepare the polyethylene by adding a number of ethylene molecules. So we prepared polyethylene. So in the same way, polyvinyl chloride also prepared by taking a number of vinyl chloride molecules by undergoing addition polymerization. So what is addition polymerization means? Nothing but we are adding a number of monomers, a number of vinyl chloride molecules, and here we will get a chain formation and we get the polyvinyl chloride. So polyvinyl chloride is obtained by heating vinyl chloride in the presence of catalyst benzoyl chloride or hydrogen peroxide in an autoclave under pressure. So here we add the catalyst to the vinyl chloride molecules and we maintain some pressure and temperature, and here we will maintain the pressure like 90 to 110 degrees centigrade and we will get the polyvinyl chloride. So this is the polyvinyl chloride and we are taking a number of vinyl chloride molecules and we are getting polyvinyl chloride. So this is vinyl chloride. And to this we are adding a number of, here we are adding benzoyl chloride catalyst and we are going for a polymerization reaction. So we will add benzoyl chloride. So benzoyl chloride catalyst. We will apply heat and pressure. So we will get here polyvinyl chloride. So we will prepare here by taking a number of vinyl chloride molecules undergoing addition chain polymerization. So we prepare the polyvinyl chloride. So we can see the mechanism, a simple mechanism here, free radical chain polymerization. So we use the catalyst here benzoyl chloride or hydrogen peroxide. So where we get by homolytic fission of this what we are taking initiator catalyst. So formation of free radicals. So these free radicals, okay, we will add to the monomers. For example, we are adding to the vinyl chloride. So we will add this free radicals what we are getting by homolytic fission. So that we are adding that initiator free radical, we are adding to the monomer. When we add to the monomer, so we are getting monomer free radical. This is the monomer free radical. free radical. After formation of the monomer free radical, to this monomer free radical, so we are going to add a number of vinyl chloride molecules. A number of, for example, we are adding here a number of vinyl chloride molecules, means one by one we will add a number of vinyl chloride molecules to the monomer free radical, so that in propagation step we get a chain polymer, nothing but it is called the living polymer. This is called a living polymer. Living polymer. Okay. So here in initiation step, we are taking a catalyst undergoing homolytic fission. A formation of free radical is taking place. In the second step, propagation step, to the monomer free radical, we are adding a number of vinyl chloride molecules. A number of vinyl chloride molecules. So that here we can see the chain formation. Okay, chain polymer is formed. So that is called the living polymer. Living polymer. So when we want to add here, like when we want to stop the reaction, after adding, for example, 2000 monomer molecules, we want to stop the reaction. Then we go for termination step. In the termination step, so we are going to terminate, we are going to couple two monomer free radical chain, polymer chains, we are going to couple. So when we are coupling here, we can see the free radical here, nothing but here only one electron will be there, unpaired electron. So when we are adding here this living polymer chains, okay, two living polymer chains, when we are coupling, so we see here the covalent bond formation. The covalent bond formation, nothing but we are stopping the reaction, so that in termination step and polymer is obtained. So in this way, here in addition chain polymerization reaction, so in the first step initiation, we are taking a catalyst, and by homolytic fission where free radicals are formed, so to these free radicals we are going to add one monomer. So for example, vinyl chloride. So what we get? Monomer free radical. To this monomer free radical, we will add a number of vinyl chloride molecules. So we get a living chain formation, living polymer, a growing chain. Okay, so living polymer is obtained. So when we want to stop the reaction, polymerization reaction, so in the termination step, we have to couple the two growing chain polymers. Okay, along with the one unpaired electron, that is free radical. So we are going to couple. When we are going to couple, so this unpaired electron, here by sharing of these electrons, covalent bond is formed. So nothing but we are stopping the polymerization reaction and polymer is obtained. So this is about addition chain polymerization. How to prepare the polyvinyl chloride. So by adding a number of vinyl chloride molecules, so we can prepare the polyvinyl chloride. So next, what are the properties of the polyvinyl chloride? Means polyvinyl chloride is colorless and odorless and non-inflammable and chemically inert powder. Here it is like a powder type, white powder type. So it is colorless, odorless and non-inflammable and chemically inert powder. And also it is resistant to light and atmospheric oxygen and inorganic acids and alkalis. But it will be soluble in hot chlorinated hydrocarbons such as ethyl chloride. So when we take here polyvinyl chloride in hot chlorinated hydrocarbons, it will be soluble. Like example, if we take the ethyl chloride, but it is resistant to light, atmospheric oxygen, O2, inorganic acids and alkalis. And it has a specific gravity of 1.33 and melting point will be 148 degrees centigrade. Melting point will be 148 degrees centigrade. And it is strong and brittle. Polyvinyl chloride is strong and brittle. And polyvinyl chloride, it is not stable to heat. It is not stable to heat and UV radiation. It undergoes degradation. So it is not stable to heat and UV radiation. So these are the properties of polyvinyl chloride. So what are the applications of polyvinyl chloride means? So here this polyvinyl chloride, it is strong and brittle. So the rigid PVC or unplasticized PVC, so that have superior chemical resistance, that have more chemical resistance and high rigidity, but it is brittle. Okay, they have more hardness. high rigidity, but it is brittle. It is easily breakable. Easily breakable. So it is used for making sheets. So we will take the sheets, polyvinyl chloride sheets, that is used in tank linings, safety helmets. So we make the helmets with PVC. We will use in tank linings and refrigerator components and tires. So rigid PVC, it is used in tank linings, safety helmets, and also refrigeration equipments and also tires. So plasticized PVC. So to the PVC, after preparing the PVC, we will add some plasticizers like dibutyl phthalate, triglyceryl phosphate. So we will add plasticizers to the PVC. So to here to increase the plasticity, to increase the flexibility of the polyvinyl chloride. So with that also we can make some products and we can use it. So it is used for making sheets, packing raincoats, and tablecloth curtains, and electric cables. We can say electric cables and toys, and radio components, and plastic coated cloth, chemical containers, thermal insulating foam that is used in buildings, and here cinema theaters and aircrafts. All these here we can use polyvinyl chloride and we can manufacture different products. So for example, we are taking already, we are discussing that plasticized PVC that is used for packing raincoat, tablecloth curtains, electric cables. Okay, in construction also we are using PVC, and we can say that the cable, and here we can for packing we are using, and for wires and cables, and for vehicles also we are using, for medical purpose also we are using, so for clothing also. So polyvinyl chloride, it is used in different ways. Okay, chemical containers like a tank linings, we use the PVC. So here in thermal insulating foam, preparing foam that is used in buildings, cinemas and aircrafts. So these are the uses of polyvinyl chloride. So next, preparation, properties and applications of Teflon or polytetrafluoroethylene. Okay, so previously we discussed about polyvinyl chloride. So how we prepared polyvinyl chloride is by adding a number of vinyl chloride molecules and by applying heat like 90 to 110 degrees centigrade and adding a catalyst, benzyl chloride catalyst, and we prepared polyvinyl chloride. And the next one is Teflon. So how Teflon is prepared is, here Teflon is obtained by polymerization of tetrafluoroethylene in the presence of benzyl chloride as catalyst. So here also we are taking a number of tetrafluoroethylene molecules. We are taking a number of monomers, that is tetrafluoroethylene, and we are adding benzyl peroxide here. Benzyl chloride peroxide we are adding as a catalyst, and we prepare the polytetrafluoroethylene. So this polytetrafluoroethylene also, it is prepared by addition chain polymerization. Means nothing but we are adding a number of monomers of tetrafluoroethylene just by adding a number of tetrafluoroethylene molecules, and by adding catalyst here and maintaining here some pressure, and we can get the polytetrafluoroethylene. So we can take here tetrafluoroethylene molecules and adding benzyl peroxide as a catalyst, and we can get the polytetrafluoroethylene. So what are the properties means? Here, due to the presence of highly electronegative fluorine atoms. So we can see tetrafluoroethylene, okay, and polytetrafluoroethylene. So due to the presence of these fluorine atoms, highly electronegative fluorine atoms, so results in very strong attractive force between different chains. So due to the presence of this highly electronegative fluorine atoms, there will be very strong attractive force between the between different chains, between different chains, there will be more strong attractive forces will be there. So these strong attractive forces gives the material extreme toughness. So the material have become extreme toughness, very hard material, extreme toughness, having high melting point. So its melting point will be 350 degrees centigrade. So its melting point is 350 degrees centigrade. The Teflon, polytetrafluoroethylene melting point is 350 degrees centigrade. And it have high chemical resistance towards all chemicals. So it will have more chemical resistance, except like when we take hot fluorine and the hot alkali metals. So here this is the property, very good property of Teflon, that is due to the presence of highly electronegative fluorine atoms, it will have very strong attractive forces, and it is due to these strong attractive forces that material it becomes extreme toughness. It have more tough, it is more tough material, and it is having high melting point 350 degrees centigrade, and it is having the high density 2.1 to 2.3 gram per cubic centimeter. So it is having high density also, and it is very strong hard polymer, very strong hard polymer, so that can be machined to drilling. So we will use that material for drilling purpose and punching purpose. We use this material, Teflon material. It is very good electrical insulator. It is also used as a good electrical insulator. It possesses very good abrasion resistance. So what is abrasion resistance means? So here when we take the materials, removal of upper layer, that is called abrasion, removal of upper layer of the material. So here in this material there won't be any removal of the upper layers due to environmental conditions or anything. So here there won't be any removal of upper layer. So it have very good abrasion resistance. So these are the properties of Teflon. So here Teflon is, it is a very tough material, and it is having high chemical resistance, and it is having high density 2.1 to 2.3 gram per cubic centimeter, and it is very strong hard polymer, so that can be used to like a machine to drilling, punching, etc. It is very good electrical insulator. It possesses very good abrasion resistance. And applications are, Teflon is a very good insulating material. Very good insulating material. So it is used for motors, transformers, cables, wires. So it is used for motors, transformers, cables, wires. And it is used in making engine gaskets. Engine gaskets, pump parts. We can make pump parts, tank linings. So in tank linings also we use the Teflon material, and also tubing. Due to the extreme chemical resistance, it is used for making chemical carry pipes. Chemical carry pipes means by using Teflon we can make the pipes. Through that pipes we can flow the chemicals. So due to extreme chemical resistance, it is used for making chemical carry pipes. And non-lubricating bearings and non-stick stopcock for burettes. So where we use the here burettes in the laboratory for titration purpose. So we use here burettes. We will when we do the titration, so we will use the stopcock. Okay, we will open the burette, we will close the burette. So that stopcock, it is made up of the Teflon. So these are the applications of the Teflon. So we can see here different applications here, Teflon. So where we can use by using a Teflon, very hard material. So you can see the door. Okay, we use the Teflon material. So here you can see the staircase. We use the Teflon. So for home purpose also we use the Teflon. So in the vehicles also we use the Teflon. So different applications are there where we are using the Teflon. So here are applications of polytetrafluoroethylene, domestic applications where we use at home, iron box. Okay, so for some cable wires. Okay, in dental field also here we can use, okay, the Teflon. So we can take here some other Teflon, like industrial wise also we can take. So bearings, okay, taps, okay, so we can use the Teflon. So these are two different, what we discussed now is one is polyvinyl chloride, preparation, properties, and applications. We can see the applications, that is plasticized PVC, rigid PVC, and plasticized PVC. And also here Teflon, preparation and properties and applications, and its applications in domestic vessel and industrial waste. There are various applications. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.